Okay, so to find some of the derivatives of trigonometric functions, we're going to use a couple of important limits. Now we're not going to actually derive these. I'll derive those separately. But for now, we'll just sort of keep in mind that the limit as x approaches 0 of sine of x over x is equal to 1, and that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. You might want to just graph these just to verify. On a separate video, I'm going to actually derive these. But for now, we're just going to keep that in mind because we're going to be using them in a little bit. Now, our task is, our first question is, what is the derivative of, let's start off with the simplest, I guess not really the simplest, but one of, sine. Now, before we actually derive it, why don't we use our tools, our graphing derivative tools that we learned earlier to try to figure it out, see what it looks like. So if I draw just, a rough sketch of sine, it's going to look something like that. Now if next to it, or how about I'll do it below so that it makes it a little easier. If I draw the same axis and we use our basic rules, remember that at the peaks and valleys, that's where my derivative is going to cross 0. So I'm going to put here f, for this is the function, in this case sine, and here the derivative, which I don't know what it is yet, but I'll soon enough find out. And then so right around here, this guy is also equal to 0. Okay. Now, if you take a look at this, well, you know that, for example, from here to here, since this guy is increasing, this guy is going to have to be positive on this green area. Then, since right here this guy is decreasing, right here it has to be negative, and the same thing over here has to be negative. And notice how it's, pretty smooth. So if it has to be positive and it has to cross here and here, so for example, for this part of it, you could assume that, something like this is what it looks like in this part. Because it has to be positive and it has to hit right here. Then it has to be negative but come back to this point. So that means that it might come down a little bit. And over here it has to be negative as well. And so what does that look like? What does that look like? Well, if you said cosine, you would be exactly correct, because the derivative of the sine function is exactly cosine of x. Okay, but I mean, that's not very rigorous. You just draw a little picture and just guess. So what are we going to do? Well, why don't we use the definition? You remember the definition of the derivative, right? I certainly hope so. Alright, so I'll write it down just in case. We've got the derivative f prime is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let's get a little bit more space over here. Alright, so what I'm going to do is I'm going to use the definition of the derivative to write down the derivative of this guy. So assuming that f of x is sine, then f prime, the derivative, is equal to the limit as h goes to 0 of sine of x plus h minus sine of x all over h. Okay, so then you think, well, what can I do? What can I do? What can I do? Well, you might remember, you know, you have all these nice little identities. You might say, I think I remember having an identity for sine where when I'm adding, you know, the sum identity, that sine of x plus h would equal to, I'm going to write it down here, is equal to sine of x cosine of h plus sine of h cosine of x. Okay. Why don't we put that into there? See if we can come up with something. So this is going to equal to the limit as h approaches 0 of sine of what I just wrote down over here. So sine of x cosine of h plus sine of h cosine of x minus sine of x. Okay, and so then, you know, you kind of look at this and you go, well, you can't factor anything. And actually, I forgot something. I need to put all of this over h. But you do notice that, and, you know, sort of keeping in mind the two limits that we in the very beginning said, you know, we know that the limit as x approaches 0 is sine of x over x is 1. Cosine x minus 1 over x is equal to 0. Now, you know, press pause right here and see if you see anything. And then try to see if you can figure out the next step. But what you can do is, and actually let me do this right here. Let me break this up into, I don't want to skip any steps. So sine of x cosine of h minus sine of x all over h, and then plus sine of h cosine of x all over h. Okay, so you might be wondering, hey, what did you do there? Well, I took this first guy and this guy and put them right here. So that's where this came from. And then this guy is just right here. And I just separated the two fractions. Now, take a look at what happens here. You've got a sine of x in common right there. And so that one you can take out. Now, I'm going to take it out of the whole limit. I'm going to just write this as sine of x times the limit as h approaches 0 of, well, what's left over is cosine of h minus 1 over h. Okay, and then you've got plus, now notice here also cosine of x can be taken outside of the limit as well. So I'm going to take cosine x out And I'm just going to, you don't have to rewrite it, but I'm going to rewrite the limit as h approaches 0. Now this is using the limit laws. Remember, you can break up the sum. The limit of a sum is equal to the sum of the limits. So I can break that up. That's okay. And then of sine of h over h. Okay, so now take a look at this. If you go back to the limits that we gave in the beginning, this guy right here, this is just equal to 0. So what I have is sine of x times 0. That's 0 with a smiley face on top. Woo! And then this guy right here, well, that's equal to 1. So what's the only thing that's left over? Well, the only thing that's left over is cosine of x. So that's it. We proved the derivative of sine. And you guys can do the other trig functions, and you would get, it's, you know, it follows similarly. So let's just write them all down. And so these are the the derivatives of the 6 trig functions. And although it looks like a lot to memorize, in reality it's not too bad, because if you look at sine and cosine, they're just opposites of each other, except one. Derivative of sine is positive cosine, derivative of cosine is negative sine. And then tangent, the derivative of tangent is secant squared, but the derivative of cotangent is negative cosecant squared. So those are similar in that respect. And these two are similar also. They're just negatives of each other. And here we have secant tangent, and here we have cosecant cotangent. So, you know, once you practice them, it's not that hard to figure them out.